Okay, so this is question number 6 out of Unit 1415, Section B, involving the binomial expansion. And there's a question that's similar to this on the assignment. So watching me do this question here should help you figure out how to do that one. What we're told is that in the expansion of ax plus by to the n, the coefficients of the first 3 terms are given by these 3 numbers here. And we want to find the values of a, b, and n. So a good place to start is with the binomial expansion of ax plus by to the n. And all we're going to need here are the first 3 terms. So our first term with k is 0 is going to be n choose 0. We're going to have ax to the n and then by to the 0. And I'm just going to put every term in the expansion for completeness at the beginning, and we'll cancel the ones that can be canceled out later. Our second term is n choose 1, ax to the n minus 1, and then by to the 1. Our next term is going to be n choose 2, ax to the n minus 2, and then by to the 2. And of course our expansion keeps going and going and going, but those are just our first 3 terms. So let's simplify these expressions and then identify, because they tell us information about the coefficients, so we want to figure out what the coefficients are going to be. Well, n choose 0 is just 1, so we can just sort of ignore that. If we do ax to the n, remember that the n applies to both the a and the x, so we'll have a to the n, x to the n, and of course by to the 0, anything to the exponent 0 is just 1. So our first term has been simplified there. Our second term, n choose 1, is just n, and if we do the expansion here, we get a to the n minus 1, x to the n minus 1, and b, and then y, because those are both to the exponent 1. Our third term is the trickiest one. There's not much we can do with our combination, n choose 2, so we'll just leave it like that for now. But we will have a to the n minus 2, x to the n minus 2, then b squared, y squared. And again, this keeps going. So if we're interested in the coefficients of these things, well, in our first term, the x to the n is going to be the variable, so we just want the a to the n as our coefficient. In the second term, the n and the a to the n minus 1 are part of our coefficient, and so is the b. And in our third term, we need this combination, the a and the b squared as part of our coefficient. So let's just look at these terms sort of in order. If we look at the first term, our coefficient is a to the n, and we're told in the question that the coefficient of the first term is 6,561. So let's put kind of a green box around that, and we're going to call that equation 1. Now let's go on and look at what information we can get from our second term. We didn't actually get like a number as our answer for the first term, but we got a relationship here that we're going to use again later. So similar thing for our second term. Our coefficient is going to be n a to the n minus 1 times b, and we know that that is going to be equal to 992. Now this looks kind of confusing, but what can we do with it? Well, the first thing to notice, I think, is I'll just come over to the side here. If we look at a to the n minus 1, if we remember our exponent rules from grade 9, this is a to the n divided by a to the 1. If we have powers at the same base, we subtract the exponents. So we can rewrite this as a to the n divided by a. So let's do that over here. This is n, a to the n divided by a times b is our 34,992. Okay. Well, if we look back up at what we had from term 1, we see that a to the n here is what we had from equation 1. So instead of having a to the n in there, I'm going to put that 6,561 in there. And what I have left after I do that is going to be n, b, and a. So I'm just going to write this as n times b divided by a. I'm going to put in my 61. And this is still equal to 992. Okay. Now, I can't solve this, but I can bring all of the numbers over to the other side here. So this will be 34,992 divided by 6561. So NB divided by A is equal to 34,992 divided by 6,561. I'm going to call that equation 2. Well, now let's see what we can get from our third term. Our third term is n choose 2, or the coefficient on our third term, a to the n minus 2, b squared. And we're told in the question that this is equal to 81,648. Well, I think you can see a little bit about where we're going to go with this. We're going to take the a to the n minus 2, and just like we did for term 2, we're going to write it as a to the n divided by a squared. So that's one substitution we can make. The thing that really gives us trouble here is this combination. So let's rewrite the combination and choose 2. Let's write it out explicitly here. This is going to be n factorial divided by n minus 2 factorial, all divided by 2 factorial. Well, we know how to simplify factorial expressions. We'll take n factorial and write it as n times n minus 1 times n minus 2 factorial. And that'll allow us to cancel out the n minus 2 factorial on the bottom. 2 factorial is just 2. So the expression we have now is, canceling out the n minus 2 factorials, is we have n minus 1 all over 2. Now, the trick that I'm going to use here, which isn't immediately obvious, is I've got an n over 2. If I look back at what I have here for term 3, I've got a b squared here. And if I look up at this thing that I'm going to substitute in for an a to the n minus 2, I've got an a squared down on the bottom. So rather than having an n, I'm going to make it so that I have an n squared. I'm going to put it multiply by n on the top and multiply by n down on the bottom. So let's make this substitution now. N choose 2 is going to be n squared n minus 1 all over 2n. A to the n minus 2 is going to be a to the n all over a squared. We're just going to have b squared, and this is still all equal to 81,648. Well, let's group all of these things together that are kind of squared. So I'll keep the n minus 1 over 2n out front. I've got an a to the n. I know what a to the n is, though. That's what we had for equation 1. And what do I have left? I have an n squared, a b squared, and an a squared. Well, what is n squared b squared a over a squared? It's relationship number 2, nb over a, just the whole thing squared. So this is 2 squared. So let's make those substitutions. We'll keep the n minus 1 all over 2n. a to the n is 6, 5, 6, 1. 2 was 3, 4, 9, 9, 2, all over 6, 5, 6, 1, and that is squared. And this is equal to 8, 1, 6, 4, 8. Okay. What we've ended up with at this point is an equation that only has n and a bunch of numbers in it. So this is something that we can solve. So first thing we're going to do is, I've got n minus 1 all over n here. I'm going to take this 2, the 6,561, and this thing, all of the things that are just numbers, and let's evaluate them. Okay, just punch them into our calculator. So 6,561 divided by the 2, because it's over 2, times this big thing squared. So punching this into our calculator, we get 93,312. How are we going to solve this? Well, if I cross multiply by the n, I'll get 81648 n over here. And if I expand, multiplying everything inside the brackets by 93,312, I get 93,312 n minus 93,312. Let's bring our terms involving n together. So just subtracting. We're going to get on the left side 11,664 n. And we're going to bring the 93,312 over to the other side, so 93312. Solving for n, we get n is equal to 8. So we've got one of the things that we were trying to find. How do we get the other two? Well, let's go back to those other two relationships that we had. Relationship number 1 was a to the n equals 6, 5, 6, 1. So if we put in 8, a is just going to be this number to the 1/8. So a is going to equal 3, just punching that into our calculator. And equation 2, if you recall, was that NB, let's see, what was equation 2 here? NB over A was equal to this big ugly mess, 34992 divided by 6561. Well, we know what the numbers of n and a are, so let's put those in. We're going to have 8b over 3 is equal to these big numbers. We can solve this for b, and we end up with b is equal to 2. So that's what we're asked for in the question, the values of n, a, and b.